Assalamualaikum. My name is Hilman Husaini bin HISHAM. I will present about investigation of wear characteristic of aluminium-based mathematic composite prepared by hybrid reinforcement. For introduction, mathematic composite is a composite material which is the combination of metric phase of aluminium and reinforcement phase represent aluminium metal metric composite. Aluminium metric composite are an important class of engineering materials that is used in automotive, aerospace, marine field, defense, and other industries. This is because they have high thermal resistance, low density, high corrosion resistance, and better mechanical and physical properties. The use of hybrid composition that contain two or more types of particles able to help others complement that lacking their own properties, and it can increase the value adds of the composition. Dora Silva said the mechanical behavior of the composite depends on the metric composition, size, weight, fraction of the reinforcement, and the method utilized to manufacture composite. For problem statement, the first one is the wear qualities of hybrid aluminum metal metric composite produced by V process and steel casting will cause a defect if the experiment is not successfully. And then the wear performance and the wear properties of hybrid aluminum metal metric composite was tested on this tester utilizing a synergistic combination of fused deposition modeling and V process, and steel casting cannot be achieved. For objective, the first one is to investigate the effect of carbon nanotube and graphene addition to reinforced aluminum metric composite. Next is to examine the microstructure evaluation in the reinforced aluminum metric. The last one is to study the wear properties of carbon nanotube and graphene addition in the aluminum composite. For the scope, the first one is the wear properties of hybrid aluminum metal metric composite that was created using a synergistic mix of fused deposition modeling (FDM), V process, and steel casting. A perforated pattern created using FDM is employed in the V process to form a hollow which is then filled with molten metal, incorporating particle reinforcement manufactured via steel casting. And then the green procedure that result allows mathematic composite to be cast quickly, and wear performance was examined on pin on this tester. And then to attain high strength, low density, corrosion resistant, easy workability, and outstanding tribological characteristic, hybrid aluminum metal metric composite are being developed. The majority of research on the tribological properties of hybrid composite has focused on the size and composition of the reinforcement, with the main focus on the optimization of wear test parameters, whereas the processing technique that govern the wear property of composite must also be investigated. The first literature review, the first one is by Janet Reno. Finding is steel casting may be used to successfully manufacture aluminum alloy metric composite reinforced with hybrid steel design and location, stirring speed and time, melting and pouring temperature, particle preheating temperature, particle integration rate, mold type and size, and reinforcing particle size and quantity are significant process factor for synthesizing hybrid composite by steel casting. Next, by Asma Wajia, the finding is the key advantage of aluminium metric composite over unreinforced materials. Strength and stiffness have both improved, and reduced density weight, improve high temperature properties, control thermal expansion coefficient, thermal heat management, enhance and Tittle electrical performance, improve abrasive and wear resistance, mass control, especially in reciprocating application, and improve damping capabilities are just a few of the benefits. And then by Ahmad, research the advantage of aluminium metal metric composite hybrid reinforcement. The finding is the influence of particle size on the hardness of aluminium 203 reinforced aluminium and found that steady particle reinforced composite had higher hardness than coarse particle reinforced composite. The aluminium metal matrix composite with silicon carbide reinforced is also a promising addition to the metal matrix composite family. Low specific gravity, excellent thermal conductivity, and low corrosiveness are all key features of aluminum SiC metal matrix composite and can operate better under harsh surface circumstances. And then, effect of carbon nanotube and graphite addition. The first one is a combination of two carbon nanofiller with different dimensionalities can provide a powerful synergistic effect that outperform the performance of each nanofiller alone. The mechanical characteristics of nanofiller are influenced by geometry and morphology of the nanofiller. And then mathematic composite with the carbon nanotube graphene hybrid nanofiller will outperform pure metal in terms of mechanical quality. The enormous specific surface of graphene and carbon nanotube is critical for producing nanocomposite with outstanding mechanical characteristics. And then, research microstructure evaluation in reinforced aluminum matrix. The finding is aluminum matrix composite reinforced toughness with linear rise in the graphite. The number of graphite particle drop content regardless of the production procedure used. And then composite aluminum matrix composite with graphite particle have a limit hardness. And then combination materials such as one-dimensional carbon nanotube and two-dimensional graphene have emerged as a significant new class of material for structural engineering and functional device application due to their extremely high elastic modulus, 1 TPa, and mechanical strength up to 130 GPa, typically 10 GPa, as well as low electrical and thermal conductive. And then, for property of carbon nanotube and graphite, in terms of tensile strength and elastic modulus, carbon nanotube are the strongest and stiffness material yet found, reveal that individual carbon nanotube shell can withstand pressure of up to 100 gigapascal. And then for methodology, for flowchart of development pattern with FDM, start with the benchmark must be met using FDM, this project, and then the 3D CAD model was translated to STL format and supplied into computer, connect to the FDM machine for component preparation. And then the investigation began with determining the optimal orientation. And then the orientation was adjusted by changing the angle along the FDM machine as YZ axis. The ram movement is specified by the X and Y axis, while the table movement is specified by Z axis. And then the component was sliced once the orientation was determined, and layer by layer building was complete before the component were cleaned. And then go to the optimal parameter were chosen based on the least amount of support and model material used, as well as the shortest manufacturing time. And then for flowchart, we process and assist steel casting. Start with under a vacuum of 300 between 400 mm. A perforate pattern was put in the middle of the base plate, and one thin plastic sheet was pulled into the pattern contour. And then on the base plate, a mold box was inserted, and the produced plastic sheet was secured with the mold box dry unbound silica and fill the mold box and is crushed for 3 between 5 seconds by vibration. And then the mold box opposite open side was sealed with second plastic sheet and then evacuated. The base plate suction was released and the mold box was turned off. On top of the first mold box, a second mold box was installed, and then the creep cavity was given proper gating, and the mold box was filled with the unbound sand and sealed with a plastic sheet. And then with the use of vibration and vacuum, the sand is compressed. The two parts had been firmly sealed, and the vacuum sealed mold chamber was ready for metal pouring. The next is development of aluminum metal matrix composite. Before changing quantity of aluminium 6063 alloy, for example, was made at 800 Celsius in the graphic crucible and the reinforcing particle. And then the double particle size and triple particle size reinforced made by combining. And then a mine steel is inserted in the molten metal up to 2/3 deep and sweep at 550 rpm. And then magnesium 1% was added throughout the steady process to increase weighting and prevent reinforcing particle agglomeration. The last one is under negative pressure, molten metal was poured into the mold and solidified. After cooling, the vacuum is released, allowing free flowing sand and fall away, producing a clean and sand-free casting. The last one is flowchart of pin on this test. And the first one is the degree of wear in any system is determined by variety of parameters, including the applied load, integral statistic, sliding speed, sliding stern appointment, and material qualities. And then, according to the STMG 99 standard, a testing pin with a diameter of 8 mm and length was made from all the casting. And then the pin contact surface was polished with 800 grit emerging paper. And then the wear test pins were side again. So the last one is to reduce inaccuracy and the associate finding of test for wear and apply frictional force. 3 repetitions of experiments were undertaken with different samples. So the expected result, the first one is to attain high strength, low density corrosion resistance, easy workability, and outstanding tribological characteristic of hybrid aluminum metal metric composite. The last one is the wear properties and wear performance of hybrid aluminum metal metric composite that was created using synergistic mix of fused deposition modeling, FDM, V-process, and stick casting, and examine on pin on this tester can get a better result. So that's all. Thank you.